with Electrical Systems 1 Test 11, and we're going to talk about these here halogen headlights. And this is basically, you know, looks like we got some true false stuff all the way through. When we're replacing halogen headlights, the technician should never touch the glass surface of the new bulb with his or her bare hands. You know about that? What can you tell me about that? Should you touch the glass surface with your bare hands? Is that an issue?
I wouldn't imagine.
It is, actually. The reason is that thing gets so hot, that little bit of grease from your fingers, and I'm talking about even if your hands are clean, the skin oil, it gets on that glass, it'll blister that thing and blow that bulb. So just don't touch it. Also, you got to remember about those halogen lights, they've got gas pressure inside of them. And technically, if they break for whatever reason, like if you scratch one and it happens to give way, it's like a little glass grenade. It throws shrapnel everywhere. So most bulbs will have a vacuum in them, right? This one here, psh, and it can blow it everywhere. Both an aiming screen and a headlight aimer are required to aim headlights. All right, what do you think? That's actually false. You don't have to have that. When using an aiming screen, and we talked about making one yesterday, you remember that? The technician should align the vehicle headlights with a mark that's usually about 50 to 75 feet from the vertical screen. That's false. We like to go 25 feet, basically. That's usually all you need. Some headlight aimers align the lamp centers with the rear view mirror, which is usually located exactly in the vehicle's center. That's false. Some headlight aimers determine the geometric position of the headlight faces in relation to each other and gravity. That is true. Now the headlight aimer that we use, you know, is actually got the little mirrors, and it, you know, you adjust the horizontal until it winds up lining the little, got the black line in the middle of the yellow field, and you can see both of them, and whenever they're lined up together, you've got them like that. And then they got a level in there, you know, you've seen that before. You guys, have you guys done that? Have you done the headlight aimer thing? You did, didn't you? And so y'all know how to do that, so this is sort of old hat for you guys. Vehicle headlights can either be controlled by a relay mechanism or a switch.
Yeah.
And that's, you know, basically where you're at. It's going to be true. You know, years ago, what we used to do was we would, when we pull the change from bright to dim, we would actually, when we pull that lever, headlights were wired through that, and that was a good tight fit, wasn't it, Danny? But the headlights were wired through that switch so that when you, and all the switches used to be that way. And I know you guys have all been around enough old cars to where you've driven a car that had the dimmer switch in the floor. You've seen the dimmer switch in the floor and all that. I had a 67 Chrysler that had a dimmer switch in the floor, and it also had another little switch right next to that that looked like the dimmer switch that was for your foot, and it was for radio seek. When you tap that with your foot, it would seek for the next radio station. And the crazy thing about it is, on some of them older cars that in the 50s and the 60s, when the radio seek function was working, on some of them the knob would turn. And then it would stop when it found the next radio station. It was crazy. 57 Thunderbird was like that, you know. But anyway, what I started to say earlier is, when we have this thing wired so that you pull the, you know, dim your headlights, the parts you were touching with your foot or your hand actually did the work. Nowadays, on a lot of these vehicles, that just sends a request, you know, changes to the body controller, and it will. The body controller operates relays to change the lights. Look at this, how this works. This is basically sort of generic, what I'm telling you about, but you'll have a body controller, and it'll have a current dropping resistor in it. Now the reason you have a current dropping resistor is if there's no load on that wire, and let's say I got 12 volts here, or 8 volts, or 5 volts, or whatever, then that current dropping resistor, there'll be voltage here, and inside that engine controller, it's got a circuit that's measuring that right there. It's actually measuring it right here. So if this is seeing 12 volts with its little solid straight circuitry. It doesn't do anything. But your dimmer switch, or whatever, is actually gonna, when you pull your little dimmer switch, this is a ground, and it's gonna short that to ground, and this 12 volts goes away. You got that? Just briefly. And when that 12 volts goes away, this little solid state thing that's reading that 12 volts downstream of this dropping resistor takes action, and it operates a relay. Now you're going to see more and more vehicles as time goes by, and there's a zillion of them out there like that now. As a matter of fact, most of the vehicles out there are going to have current dropping resistors inside here, and a lot of them will not only just have a contact switch down here, they'll have various different resistors on their switches. Like they'll have if you've got a switch that's got several positions, you may have several different resistors of varying different resistance there. And if whichever one you close, see, each one of them will be hooked to its own switch, so to speak, and it'll have a ground on each one. So if you close this one, it knows, even though it's only on one wire, it knows which one you closed. Because this resistor here may have 3,000 ohms, that may have 2,000, 1,500, or 600, you know, or whatever. And it knows because it's been programmed with an algorithm that says if the voltage goes from 12 down to 8, this is what you're supposed to do. If it goes from 12 down to 4, this is what you're supposed to do, and all that. Derek, we're going to program that engine controller. I got it set up, and I got it installed over where you can hook up to it. But first thing I want you to do is drive that Nissan Maxima out there, and it runs crappy. It's throwing oxygen sensor codes. The EGR valve's already been replaced, but he don't know if they did it right. It's just terrible. You know, it runs awful. This is not a bug anybody planted on purpose, but he's getting horrible gas mileage. And the first thing we want to do, his air conditioner's not working either, but the first thing we want to do, and since you're doing the engine performance thing, and I'm sure you can find a worksheet that will line up with this amongst the ones I've thrown you, that it runs horrible, and we need to see with our scan tools and whatnot what we need to do to fix that. Okay, and he said that, you know, he doesn't have to have it back today, but as soon as you can troubleshoot it and find out what's wrong, I need to know what you come up with on it. And I think the spark plugs have already been changed, but he said that he put the plugs in it, and he doesn't know if the ones that are in the back were put in there right, and I don't know what he meant by that. You know what I mean? So you see where I'm going with this? Yeah. You know, so just what we need to do is try to return him to factory running and gas mileage. That's what we're trying to figure out. And let me know what you need. He's got a work order in there already. Just go for it. Hey, and if George shows up, grab him and get him to help you and interface with him. You know what I'm saying? All right. All right. So, but anyway, this kind of stuff right here is what you're going to see. I tell you something else that I almost forgot to say. The cool thing about having this handled by a computer, and it sounds a little bit scary if you're not thinking clearly, you can plug your scan tool in and talk to this module. And it'll have a PIDs that'll tell you about the positions of these switches. You see what I'm saying? So it's really handy to plug that scan tool in and let the scan tool do the work for you. Now, if you're not getting anything when you change your switch and the switch has already been replaced, then you got to dig into your wires with your meter and stuff, but that's just no brainer. Headlight switch is a heavy-duty current carrying device that can easily be located anywhere within the driver's reach. Is it? Headlight switch is a heavy-duty current carrying device that can easily be located anywhere within the driver's reach. That sounds like a true question, but nowadays most of them don't carry the current. They operate a relay. You remember? So I mean, if that one there, I would say if I was taking this test, I would put true, but I'm telling you the answer key says that it's false. You know, and it actually, and on the older cars that would have been true. It was a current carrying device. I'll tell you something else. On the ones that had it that way, like the older ones that had a headlight switch that was right there, that, you know, was carrying the current, there was a circuit breaker built into that light switch. Okay, and you know what it looks like when there's a circuit breaker when you're looking at a schematic and you got a headlight switch with a circuit breaker built into it. you'll be looking at your switch, you know, your dynamics of your switch and all. Right? It'll have the power coming in here, and inside the switch, you'll have this, and then it'll be feeding all the circuits in the switch. Now, what are the ramifications of that? You know, you'll actually have your switch, you know, doing all the stuff that it does, and lights, you know, being powered up and all that. Okay, so what happens here? That circuit breaker is a self-resetting circuit breaker. And ever since headlight switches have been out there, and let me grab one like I'm talking about. Let me grab one out here on my bench. This headlight switch here is the kind that I'm talking about. And that headlight switch there, it's got a stem got the knob goes in here, and you push this button on that kind of headlight switch to get that out of there. If you got a headlight switch, it's one of these that you pull the knob. If you'll reach in there behind the dash, you'll feel this little button. That was a standard headlight switch, current carrying headlight switch for years. And that son of a gun would, when you mash that button and fool with that, it just come right around. When you put it back in, you just click it back in there, you see. Well, the long and short of it is the little resistor for your instrument lights was also built right in here, and it also was able to turn on your overhead light. But you can see that little, if you look real good, you can see that little resistor right there. Right there. You see it where it slides around. Look at that. All right, that headlight switch has got a circuit breaker in it too. And if that headlight switch, if it gets hot, ding, 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 you know, and all that.
Is it this metal part?
What do you mean? Yeah, that little, if you look in there, the little part where that, you got a little metal contact that's sliding on that little piece of resistive stuff. And that's how it changes the bright and dim of the dash lights. But the long and the short of it is, the first time I ever knew about those things having a circuit breaker in them, I was working at Ed Davis's back in 77, and there was the guy that I was working with was changing a headlight switch on a LTD that was a 72 model, because when you left the headlights on for a while, they'd start winking off and on by themselves. They just off and on, off and on. And sometimes when you put them on bright, they would do it worse than they would on dim and this kind of thing. And so we've changed a bunch of headlight switches for that. The reason they do that is because that circuit breaker is opening and closing. It gets tired, and so you got to replace a headlight switch. Those headlight switches don't cost much, but I will tell you that on that particular headlight switch there, it came out of that 94 model Jeep Wrangler that Zach Beck's mother drives, and the connector was burned up. You know, if you pull it loose and you look at it, you burned up connector. Sometimes it just does that because it's carrying a lot of current. High current carrying circuits do that. But anyway, while procedures for replacing most lighting system components often vary, the procedure for replacing the headlight switch is usually the same. And you know, that's false too. You know, it's going to level be anything there. You remember that story I told you about the Explorer that burned up the headlight switch after they drove all night? You remember that? They had that thing, they burned up a headlight switch and I put a relay in there. You remember how I drew that on the board and all that stuff? Just remember that. A lot of the times if you've got a current carrying switch that is actually being destroyed by the load that it's carrying, and there's nothing wrong with the load, then you may have to fix it so that a relay is carrying that load and your switch is just turning on the relay. So just remember that. Sometimes that's the best way to fix something like that. But you also need to make sure by measuring the current that you don't have a bigger problem somewhere. You know, if the lights are burning at the normal intensity, and I'm talking about blowing fuse, I'm talking about, let's say that you've replaced whatever this switch is and it starts to get hot and give trouble again, and they've added some lights. The most common places this happens is where they've added a bunch of lights, or on a motorhome where on the back of the, you know, these F-53 chassis where Ford sells them a chassis and they put their own motorhome on it, and they put great big fine bright, now they're using LEDs, you know, they don't burn much, but back when they put big old fine bright lights on the back of them for your brakes and your turn signals, when you got your foot on the brake a lot in traffic jams and stuff, it would, the little plastic stoplight switch that they were using on those platforms would burn up and they wind up with no stoplights, you know. And so what I would do is, they actually came out with a more robust switch, but I still didn't trust it because it looked about the same. And I would actually take that switch and wire up a relay so that the switch was, all it was doing was clicking the relay, and the relay was carrying the lights. And that was a good fix, and it never came back, you see. Because you still had fuse protection. You know, I'd take the, do you remember how I showed you that I did that? Could you draw that?
No.
You couldn't draw it? I need to draw it again so you'll know how it's done. This is pretty important to know. This is what you originally had. It won't take me but a second to do this. So anyway, this switch right here is basically going to represent your stoplight switch. B plus, and let's say we got a fuse here, right there. See that? There's your fuse. And then when you mash the brakes, this is going to make contact, and it's going to send power out to all of these big old lights. Like that. And it's a parallel circuit. They're all coming on at the same time. We're just going to act like they're stoplights. We're leaving the turn signals out of it. Okay, you got that? All right, now, if you're going to put a relay in here so that switch was not going to be doing anything except pulling the relay, how would you go about it? You've already got a power feed, right? Huh? All right, let's take a black marker here. This is going to be our added stuff. All right, you got a relay coil right here. All right. There you go. There's your, this right here is your normally closed. You're not even going to use that one. Just forget about the normally closed one. That's the one in the center of the relay. On this one here, what I'm going to do is I'm going to cut this wire right here. All right. And then I'm going to take this wire right here, and I'm going to go right over here with it. All right. Down here I'm going to have it grounded. So what's going to happen now when I mash the brake? This relay is going to go click. Right? I'm going to hear the relay click. Well, I'm going to take this power that was originally feeding into that, which I'm just going to let it stay. I won't let it stay there. And I'm going to take that power, and I don't really have a good way to draw it on here without crossing over another thing. But I'm going to run that power right here. And then I'm going to take this and run it right there. Everybody understand that? I'm going to bring my power. See, it doesn't hurt for the same power that powers up the coil to power up the common, you see. The switch is only going to be engaging this, and it will last forever pulling that little coil. The relay is made to pull 30 amps or something like that. And so whenever that power that's still fused, because you want to come off of this, you don't want to cut the power going to here, you want to leave the power there. It's actually going to feed that, and then whenever it clicks, and then you're going to have your stoplights. Got it? I've actually seen interior lights in some of these conversion vans. Whenever they buy that conversion van, they buy a gutted van. It's got nothing in it but one little dome light. And that one little dome light is fed by a little teeny 22 gauge or 24 gauge wire, because they feel like that's all it needs. Well, the people that build the conversion van, they add all these fancy theater lights and all that hogwash in there. And then they just come off of that same little bitty wire to feed all those lights. You know, what does that do? That burns up all kinds of stuff. I mean, it causes issues, messes up switches and stuff. So I have to do something like that on here. See? But in a lot of cases, you got to pull a stronger wire to pull a theater light. Anyway, sometimes you run into situations where you have to do that. All right. Okay. Let's see. That was number 10. Upon application of the brake pedal, the brake switch contacts closed, and that energizes the brake circuit. And that's true. That's not a rocket science. There's 3 basic types of small lamps: square, block, wedge, and miniature bayonet. That's false. Good grief, there's all kinds of lamps. Wedge lamps are gripped by metal fingers in the socket, and you can see in your book what they're talking about when they say wedge lamps. That's true. Miniature bayonets look like small tail light and stoplight bulbs, and that's true. And then 14, small lamps are used in courtesy light systems, and then 15, that's true, and so is 15. Small lamps are used in dashboard lighting systems. I will tell you this, there was a Ford Lightning that had one of those white instrument clusters on it, and that white instrument cluster was not working, and so I says, well, I'm talking about the light part of it wasn't working. I said, I'll just go in here and find these here bulbs. And that instrument cluster face didn't have no bulbs going to it. The whole doggone thing lit up. I mean, this was a piece of plastic thing that had needles and, you know, numbers and all on it. And when I pulled it out and flipped it over, it actually had 2 wires going to it, and whenever you fired those up, that whole thing would glow. It was kind of like an optic fiber deal or something like that. But anyway, that was just something I won't charge you anything for that little story there. All right, so that pretty well got that test covered there on that. Is there a test from last week that we didn't do, Daniel? Did you still have? Did we do test 10? Because I think last week we had that one day we put that off or something. You still see it in there?
I've got, yeah, electrical systems.